Hello, these are your notes for your sum and difference identities. So these formulas are actually given to you on your reference sheet. So I'm just going to give the formulas to you, the identities to you. You don't have to memorize these. If you're interested in knowing where they came from and you want to see the proof, I'm very happy to provide that. I just want to show you that you just are given the formulas, and the whole purpose of this lesson is just how do we use these formulas. So here I have this identity. I can also call it a formula. Cosine of alpha plus beta equals that lovely thing, and then cosine alpha minus beta. The reason these exist, so let me actually just show you. This is the reference sheet you're allowed to use. All right, so what we're looking at right now is we're going to see how we can use these two. Now, so we're using alpha and beta. Our reference sheet uses A and B. All right, so A is alpha, B is beta. The reason we have these is because we have this beautiful unit circle that we have been messing with for so long. But we only have certain values, right? We only have pi over 6, pi over 4, all these, love these reference angles that will create special right triangles. And so that's how we have these exact values. But realize there are other angles happening, right? We don't have just pi over 6, pi over 4. All these angles are happening in between. So we wanted to figure out a way of how we could evaluate without relying on a calculator other values that we can't see on our unit circle. Doesn't mean they don't exist. So if I look at cosine of 195 degrees and I bring back that unit circle, I don't see 195 degrees on here. But maybe I could break up 195 degrees to be two measures on this unit circle that I do know to create 195 degrees. So this is, if it doesn't say exactly use the sum formula or the difference, you get to choose. So I'm going to move this thing over a little bit. So when I look at 195 degrees, one way I could break that up is cosine of 60 degrees plus 135 degrees. There are other ways to break this up. We could have done the difference. I just chose to do the sum. So that's letting me know that I will be using this identity right here. Okay, now make sure this does not equal, this is not the same thing as saying cosine of 60, get rid of that, 60 plus cosine of 135 degrees. That is not the same thing. You cannot distribute a function. So don't do that. I'm going to get rid of that so I have space. So now I'm going to use, and again, you'll always have this to refer to. You don't have to have these memorized. I'm going to use this. So it says the first thing is, so this is my alpha, this is my beta, or my A and B. I'm going to say, okay, well, this is cosine of 60 degrees times cosine of 135 degrees minus sine of 60 degrees sine of 135 degrees. And you have that unit circle hopefully memorized. I'm going to go ahead. Let's go get rid of this stuff so it doesn't get confusing. And I'm looking at 60 and 135. So I'm going to just focus my attention here and here. All right, the first one says cosine of 60. Well, cosine of 60 would be 1/2 times cosine of 135 negative root 2 over 2 minus sine of 60 is root 3 over 2 times sine of 135 is root 2 over 2. And then we're going to go ahead and clean this up. So 1 times negative root 2 is negative root 2 over 4 minus, and hopefully you're feeling okay with radicals, root 3 times root 2 is root 6, and that's over 4. So you can leave your answer like that. We cannot combine those radicals, right? They're not like terms. Or you can take it one step further and put it all over 4. The nice thing would be is at the very end, you say cosine of 195 degrees equals. So if I were to go to Desmos, and let's make sure we're in degrees because 195 is in degrees. I do cosine of 195 degrees. I get out that decimal. But realize in your homework and in class, I'll always ask you for the exact value. So you cannot give me the decimal. So you cannot use your calculator. But if I were to put in what I found my answer to be, which was negative root 2 minus root 6, and I divide that by 4, we get the same exact value. We much rather have this radical answer because it's the exact and there's no rounding happening. So you are forced to use these formulas. All right, when it's with degrees, I do think it's easier for us because it's easier to break up. Let me get rid of this. When I have a fraction, when I'm in radians, when I have 7 pi over 12, all right, I have to think about how I'm going to break this up. Again, you have the freedom to choose between using the sum formula or the difference formula. Because these are your notes and I just showed the sum formula, I'm going to choose to use the difference formula. So now I'm going to use this one. So this takes a little time to figure out how to break up 7 pi over 12. So like one option would be, all right, so it is 8 pi over 12 minus pi over 12. The reason that will give me 7 pi over 12, but there's nothing on the unit circle that is pi over 12. So it's not going to help me. So you're trying to think of two fractions that will reduce to something that is in fact on your unit circle. So it might be a little bit of trial and error. But what I came up with is cosine 15 pi over 12 minus 8 pi over 12. Another option is to go ahead and change what's on your unit circle to have a denominator of 12. So if I put this back up, it gets a little messy, but you could change these to have a denominator of 12 to see what you could combine to get out 7 pi over 12. Or you could do trial and error. So again, if you subtract those, we do get the same thing we're trying to actually evaluate. But now what we're going to do is we're going to reduce those fractions. 15 pi over 12 reduces to 5 pi over 4. And 8 pi over 12 reduces to 2 pi over 3. And those two things are on my unit circle. So I'm always going to refer to the identity. I'm never going to try to memorize it. I have it in my reference sheet. And so this says, and I'm just going to provide myself a little bit more space. So it says cosine of your first alpha times cosine 2 pi over theta. Don't put that negative there because it's taken care of inside the identity, the formula itself. So don't worry, don't put in negative 2 pi over 3. So then it's 7, sine of 5 pi over 4 times sine of 2 pi over 3. So bringing back that unit circle, I'm going to focus my attention at 5 pi over 4 and 2 pi over 3. So cosine of 5 pi over 4 is negative root 2 over 2 times cosine of 2 pi over 3, negative 1/2, plus sine of 5 pi over 4, negative root 2 over 2. And then sine of 2 pi over 3, root 3 over 2. If I go ahead and multiply, I will get a positive root 2 over 4 minus root 2 minus times root 3 is root 6. So you can leave it like that, or just ran out of space, so I'm going to move this way. You can put it over the same denominator, but that is as far as you can go. You can't combine those things. So cosine of 7 pi over 12 equals that exact value. So it's pretty close to the other one. So the whole purpose of this is just teaching you how to break up an angle you're trying to evaluate into two things you actually can find on your unit circle. So for C and D, these are actually already broken up for us, okay? So this is kind of like working backwards, or not working backwards. It's like they already gave us this step, which is nice. So this acts like my alpha, and this acts like my beta. So I'm going to go ahead and just use this formula. So because it's pi over 2 minus theta, I'm going to use the one that's highlighted, the difference formula. So cosine of pi over 2 times cosine of theta plus sine pi over 2 times sine of theta. And so what happens here is cosine of pi over 2, if we look at our unit circle, that gives me 0. I don't know what cosine of theta is, I'm going to leave it, plus sine of pi over 2, look at that unit circle, we get 1. And then we multiply it by sine of theta, because I don't know what it is, because it's a variable. Well, 0 times anything is 0, and then 1 times sine theta, we just get sine theta. So this was kind of cool. I added this because, what do you know? This is that idea of cofunctions that we've learned already, right? Remember the cofunctions? Pi over 2 is equivalent to 90 degrees. So we talked about in the past that like cosine of 60 degrees is the same thing as sine of 30 degrees. And so this was just another way to prove that using these identities formulas. And so if we go ahead and we are going to actually hold off on doing D because we don't have that formula quite yet. So we'll come back to D after the next set of videos.